All right, so let's look at the B5 notes. So the idea here is that the part that's inside of the square root, right, we're going to break down into its prime numbers. So what's a prime number, you may ask? A prime number is going to be a number that is only divisible by 1 in itself, which you may recall. Here, look, I'll write them down. The primes are 3, 2, 3, 5, 7, 11, 13, 17, 19. I mean, the list goes on and on. There's infinitely many, right? But typically, we hang out in this section right here. 2, 3, 5, 7, 11, and 13. 13's pushing it, but for sure 2, 3, 5, 7. Right, maybe 11, but 2, 3, 5, 7 for sure. Okay, so keeping that number in mind, or that list in mind, I'll leave it at the top. All right, number 1, 3 times root 12. So we want to rewrite the radical, the square root, in terms of its prime numbers. Right, so typically you always start with like 2 or 3. I always start with 2. So 2 times what is 12? Right, 6. And then you break 6 down. Again, 2 times what? It would be 3. So what we have is that 12 is broken down to 2 times 2 times 3. Okay, here's the deal. You can take out, right, you can pull out a number, but only if it's in pairs. So if you look at the notes, you're looking for pairs. That's the clue. So there's a pair of 2's. Now, the 2's can come out of the square root as a single 2, right? Anything that's a pair can come out as a single number outside in front of the square root. And it has to multiply by whatever's in front of the square root. So in this case, there's a 3 in front. So this is going to be 2 times 3, right? It has to multiply here. So 2 times 3 is 6. And then the square root, and then whatever's left over. The 3, right? This is the leftover part. And this stays inside. Stays inside. So 6 root 3. Let's try it again. So again, recapping. You break the inside part down into its prime numbers. You pull out any and all pairs as a single number, multiply them if there's multiple ones, and you put it in front outside of the square root. Whatever's left over, basically no pairs, right? If it's a single number, it stays behind and it stays inside. So let's look at 80. Square root of 80. So this is really 2 times 40. 40 is really 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Again, down to its prime numbers. How many pairs do I have? This pair can come out as a 2, a single 2. These pair of 2's can come out as a single 2. And then 5 is left behind, right? Left inside. So in front, we have 2 times 2, right? All the things that come out get multiplied. So this is going to be 2 times 2, which is 4. And square root of 5, because that's what's left behind inside. Hopefully you get what I'm saying. Let's try it again. So 6 root 54. So inside, I can multiply this by, let's say, 2. So 54 divided by 2, 27. 27 is 3 divided by, or 3 times 9. And then 9 is 3 times 3. So let's look at our pairs. We only have one pair of 3s. So this 3 this 3 is going to come out as a single 3. And then what's left behind? 2 times 3. A 2 and a 3 this time is left. So these stay. Okay, so outside there was already a 6. So 3 times 6. Right, 3 times 6 is 18. So 18 square root. And then the part that stays inside is 2 times 3. So 6. So this is 18 root 6. So pairs leave as 1. If multiple pairs leave, then you multiply them together. If there's something outside, you multiply it by that. And then all the singles that are left behind get multiplied and they stay inside. Let's try another one. 27. 27 is really 3 times 9. 9 is 3 times 3. So what gets pulled out? A pair of 3s. So this goes out as a single 3, and it gets multiplied by whatever's in front. So -5. So 3 times -5 is -15. What's left behind is the single, right? This stays. So square root of 3. So -15 root 3. That's our answer. I feel like it goes fast, but maybe it's just me going fast. See if I can go slower. Okay. 2. Always start with 2 or 3. Half of 240, 120. 2 again, right? Because it's an even number. 60. 2 again. 30. 2 again. 15. 3 and 5. So we broke it down into its prime numbers, and we circle all the pairs. 2, 2. So this will leave as a 2. These will leave as a 2. 3 and 5 stay behind. So outside, 2 times 2, right, is 4. Inside, 3 times 5, 15. Okay. That's multiplying. All right. Let's look at the next topic. Okay, now we're simplifying the variables. Okay, so here, what's happening, right, is that each variable is going to be handled individually. And you're looking for pairs, triples, quadruples, right? 4s. So let's kind of like break down what's happening. So really, x to the 5th is saying 5 times, right? 5 x's. X to the 5th, that's what it's saying, that there's x times x times x times x times x 5 times. Okay, so what we want to do, now you don't need to do this every time. Like I'm just doing this one time to show you, but you can take out the pairs as single x's. Right, this is going to come out as an x. This is going to come out as an x. And then this one stays behind. So what's happening is that what we have outside, we have x squared. And on the inside, we have just an x. So you have to like kind of like ask it. So, right at the end of the day, you're taking out pairs. That's the bottom line. But it's like, how many pairs can I take out? Right, and how many twos are in 5? Well, 2, right? Because 2 times 2 is 4 with 1 left over. Um, yeah. So, well, let's try the next one. Maybe it'll make more sense. Um, so x to the 4th and z squared. So remember, there's 4 x's here, right? There's 4 x's, but I can only take them out in pairs. So it's like there's 4. So I'm taking 1x, 2x, right? 2 x's are coming out, right? Because like I'm bringing out 2 sets of pairs. So this would be, right, comes out as an x, comes out as an x. So this is going to be outside x squared, right? Because x times x, there's 2. And then there's no x's left inside. There's an x squared left inside. So there's 2, or z squared rather, I'm sorry. There's 2 z's. So I'm going to take both of those out as a single z. So there's literally nothing left inside, right? So, I mean, I guess I could have drew it like this. What I don't want you to do is like, oh, there's 2 x's, right? That's not the case at all, right? Because when you multiply variables, you add the exponents. Okay, one more time. Okay, so here, number 8. So let me I kind of wish this wasn't in here. Okay, so look, what you're not being told is that when you have a square root, there's an invisible 2 in front. That's why we call it square root, right? Anytime there's no number, it's understood, like everyone understands that it's a square root. Hence, that's why we're taking out 2, right? Because it's a square root. We're doing it in pairs. Here, a cube root, anything above a 2, a cube root, 4th root, 5th root, the number's there. But for square roots in particular, we don't write the 2, right? It's just known that it is a 2. So here, for the cubed root, this means take out triples. So for a cube root, we're pulling out things of 3. So for instance, cube root of x to the 9. That means there's 9 x's. Right, there's 9 x's. So that means I'm going to pull out triples as a single x. Triples as a single x, and triples as a single x. All to the front, all outside. So what's left is x cubed, right? Because this is x to the first, x to the first, x to the first. So when you're multiplying variables, you add the exponent. So 1 plus 1 plus 1 is 3. So the root is how many you're taking out. So here we're taking out triples because it's a cubed root. Okay, let's look at number 9. Number 9 is a cube root of 81x to the 11. All right, so let's look at the number first. So this is going to be, so 81 is 9 times 9. 9 is 3 times 3. 9 is 3 times 3. And then there's 11 x's. So you could say 3, 6, 9, 11. Okay, so if I'm taking out triples of everything, right? Triples. So 3 threes. 3 threes will come out as a single 3. So there's a 3 in front and a single 3 left behind. And then as far as x's are concerned, there's 1x, 2x, 3x's, and an x squared left behind. So answer is going to be a 3 outside, x cubed, right? Because an x, and an x, right? 3 x's get pulled out, so that's x cubed. And then what's left behind? All the singles, or the things that didn't come out. So a 3, and then x squared. It's kind of fun, right? It's kind of fun. Here we have a fourth root. So we're pulling out things in fours, in sets of fours. So how many sets of fours are in 12? That's the question. There's 3, right? Because 3 times 4 is 12. So there's 3 sets of 4. So x cubed is coming out. Now, for the y, there's 4 sets of 4, right? Because 4 times 4 is 16. So there's 4 sets. And then there'll be a single y left over. Right? If you don't believe me, right, there's, oops. So I'm pulling out, so here's 3 sets of 4, right? That's why x cubed. And then as far as the y is concerned, for the same reason. Right, 4, 8, 12, 16, and 1 left over makes 17. So you don't have to do this every time because this takes up time. So if you just know the multiples of the number, it really comes in handy. Okay. Here, notice no number. So it's a square root. It's understood that it's a 2. So we're taking out all the pairs of everything. So 2 times 10, 2 times 5. So this will come out as a single 2, and it'll multiply against the negative 5, so negative 10. Not only that, but how many 2s, pairs of 2s, are in 11? There's 5, because 2 times 5 is 10, with 1 left over. So x to the 5th. And the thing that's left over, a single x. All right. We're almost done. Okay. When adding and subtracting, basically we treat them like variables, right? We treat them similar to variables. You can only combine them if they're like terms, right? If they're not like terms, meaning whatever the root is, then you can't combine them. So the number under the radical must match, right? So for instance, here, root 2, this can only combine with root 2, right? Treat it like apples or inches or some sort of variable, right? 6 apples plus 2 apples, or 6 root 2 plus 2 root 2. This makes 8 root 2. And then the part that's left over is 5 root 3, right? Root 3 and root 2 are different, right? Are different. You can only combine things that have the same square root number, square root value. So let's see. So here, you're like, oh, I can't do any of these. Okay, well, there's like a caveat or a kicker to this is that you have to simplify first and then add. So we can simplify 18 into 2 root 9. 9 is 3 and 3. So the 3 is going to come out, right? 3 is going to come out as a single 3. So 3 root 2, right? Because the 2 is left behind. Plus 4 root 2. I can't do anything with that. And then 50 is 2 and 25. 25 is 5 and 5. So the 5 can come out as a single 5. Right, a 5 can come out as a single 5. And then the 2 is left behind. So root 2. So this is going to be, notice, this symbol is minus. So negative 5 root 2. Now, they all have root 2, right? Root 2, root 2, root 2. So all the things are alike, so we can combine all of these. So 3 plus 4 minus 5. 3 plus 4 is 7. 7 minus 5 is 2. So the answer is 2 root 2. Right? 3 plus 4 is 7 root 2. Like, again, treat it like a variable, treat it like apples. Right? 3 apples plus 4 apples is 7 apples. Minus 5 apples. Oh, it's 2 apples. If you treat it like apples, you'll never go wrong. So the big thing is that they all have to be the same. Lastly, multiplying. So when multiplying the radicals, the outside with the outside, inside with the inside, and everything's being multiplied. Right? Outside number times the outside number. And then inside number times the inside number. Okay. So outside times outside. 2 times 3 is 6. Square root. Inside times inside. 5 times 10 is 50. There it is. 6 root 50. Okay. Now, once you multiply, you always have to remember to simplify. So this is going to be 2 times 25. And this is going to be 5 times 5. So the pair of 5s comes out as a single 5 and gets multiplied against the 6. So 5 times 6 is 30. Square root of the part that's left over, 2. So 30 root 2. Okay. One more time. So outside times outside. Negative times, there's nothing in front of 15, so it's a 1. So this is going to be negative, right? Because there's a negative outside. And there's no other number. All right, inside, however, 6 times 15. So this is going to be 6 times 15. So 30, 60, 90. Okay, now that it's multiplied, now we simplify. Let's go 3 and 30, 3 and 10, 2 and 5. So what comes out? A single 3. And then what's left behind? 2 times 5 is 10. So final answer, negative 3, square root 10. -3 root 10. Is that it? All right, that's it for today. Good luck.